My name is Andy Whitaker. I'm a consultant with the state of Indiana, and I spent the last 10 years modernizing applications, working within the government sector. I'm happy to talk to you today about our journey with Event-Driven Microservices.
Hello, my name is Joe Corey, and I've been leading modernization projects for over 10 years at the state of Indiana across multiple agencies. So we first want to thank you for joining our session, and we really appreciate any opportunity we get to discuss the accomplishments of our team and our adoption of event-driven microservices. So we first want to talk about our transformation. And what you're seeing here is a timeline of our transformation from monolithic applications in 2016 all the way to the start of our change to event-driven microservices by the beginning of 2019. And you're seeing here not only the change in the architecture, but our adoption of the new technologies along the way. And today we're going to be discussing how we were able to make this change, which started at the end of 2017 and then evolved into actually rebuilding 2 systems through 18 and going live at the end of 2018. And we're not going to stop there. We're also going to be discussing the outcomes and how our team is able to continue to change and evolve since that time into what we are currently. Our agenda today is going to be to review the challenges we faced with our environment, talk about the evolution of our event-driven microservices with the support of the Axon Framework, and then also discuss the changes in our development approach. And it's really, truly quite amazing what our team has been able to accomplish over this time period, given the challenges you have with the state environment and the culture. So first we want to look at, how do you make a transformation from the monolithic application that you see here to the microservices with CQRS with event sourcing? This can be quite challenging, and this is one of the 2 applications, the benefits portal, that we actually rebuilt and transformed. Next, along with that architecture change, we were actually able to save the agency a lot of money. Nearly $700,000 a year with our change. And yes, primarily that is due to licensing reductions, hosting costs, as we adopted Docker and containerization. But there is real business value in making this type of architecture change. What you won't see on here is anything related to staffing. We had to work with our existing staffing. We couldn't make changes to the team. And then you say, well, how do you achieve a targeted business outcome with the delivery of change after you go live with the architecture? Well, for us, in 2019, we were able to deliver nearly 5 times the amount of change in a single quarter than we were with the previous 6 years that we had been supporting these other applications, these other monoliths that we had built. In fact, if you look at the year-to-date total for the previous 6 years, supporting about 6 different monolithic applications, we only delivered 54 releases. Yet for 2019, with the 2 systems that we transformed into the event-driven microservices, we were able to deliver change 65 times. And this is 0 downtime deployments. This is now deploying individual services instead of the whole thing. This is getting away from long deployment times on the weekends. So now we want to talk about the challenges that we had when we were able to take this on, and give a little context to state government. We realize we're speaking to an international audience, and not everybody might have some background with what it's like to work within state government. So in the United States, the federal government has a series of programs. I mean, they have many programs, but the ones we're going to discuss today, they have these programs around providing medical benefits or health care, providing nutritional benefits, subsidizing health insurance, and also cash assistance. And these programs are to design people that have a need and qualify for these types of benefits. But every state is responsible for supporting and implementing the policies around these programs. Each state can do it differently. But in the state of Indiana, they have one agency called Family and Social Services that is responsible for supporting these programs. And they do that through a system they call the eligibility system. This is a very simple view of the eligibility system. It is a real important system, makes up a large amount of the resources, IT resources of the agency. But one of the reasons it's so important is because you don't want to have disruptions to the benefits or that are provided, or people's potential to receive benefits. And particularly when you're in a political environment and you happen to be maybe in an election year, any issues there can typically make the news. And so there's a lot of pressure to not have any issues with the system. Now, in terms of the kind of size of the system, I mean, again, the eligibility system, you can think of it as an intake system for applications, a large case management system. There's complexity around eligibility determinations and then redeterminations. So there's a lot there, even though it looks so simple. There are, at any given month, there are about 1.5 million recipients receiving benefits. On a typical month, there'll be 120 applications received and processed in a given month. We have over 400,000 registered clients checking on their status or applying through the portal. Now, in state government, there are many challenges with implementing IT solutions. And a lot of that is driven by the fact that there are limited resources within state government. This can be with talent, this could be the number of people, this could be budgets. And all of these things lead to the fact that, state IT organizations are not lean. The organization as a whole are not lean. Certainly, they're not agile. And it's really difficult to get these organizations to adapt to new technology and change their processes. So what often happens in a state agency is when they have initiatives to modernize their systems, then they reach out to big service integration providers. And all of you probably know, can think of a name of a big consulting company that does this type of work. Now we're going to give you an example of a modernization for FSSA in the year 2020. So again, here is the view of the eligibility system. And we're specifically going to be talking about the caseworker portal and eligibility determination. Again, this is, although simple looking view, this is a very complex system here, sub-component of the overall system. It does benefit calculations, benefit redeterminations, a lot of complex workflows, has to comply with MARS E2. the feds typically subsidize these modernization initiatives, so there's a lot of compliance and reporting that has to be done with these systems. So the state modernized and finally, after 8 years, rolled out a modernized caseworker portal to the entire state just last month. And this took them over 8 years. Keep in mind, this was a COTS product. The cost for this initiative was over $400 million. And what do they get with that? They get a large monolithic system, a system that's based on a stateful EJB framework. The UI is JSPs. And if you look at the images that we've attached to the slides, what you'll see is a large infrastructure that needs to support the monolithic application. You'll see that they have a batch catalog that has over 500 batch jobs for production. So you can imagine the cost to maintain and manage this type of system. And just as we all know, with a monolith, that cost is just going to go up and up over time, let alone the type of technology that is being used to support this system. Now, all this information is actually publicly available, and I've actually included a URL to where you could see and confirm this information that we provided. So next we want to talk about the struggles of our team, and in particular talk about our processes. So before 2018, when we literally built about 6 different systems, primarily pure monolithic type applications. We had processes that really weren't efficient and could not support any kind of change we had. We had builds that were specific to environments. We didn't have pipelines. We didn't have automated testing. Very few unit tests within our code. And all of this led to kind of forming silos between our processes and our team members and how they executed. In fact, most of our deployments that happened maybe on a nightly basis were all driven by moving code with properties that had to get to servers, with database changes that need to align with that. So a lot of inefficiency with our process. Then now within the individuals, our team itself, that we had 15 resources that included developers, DBAs, admins, and we didn't have a DevOps culture. Instead, what we'd had is a group of people that had really come complacent, stagnant with their growth in terms of new technology, a team that was afraid of risk, afraid to try the unknown, didn't want to make mistakes. So, it's difficult to have a transformation when you have this type of environment. Now, what we did have with our team is we had a lot of trust and a lot of commitment, and that is a good foundation to start moving forward with. So now we want to start talking about how we reached a certain tipping point in 2016 and 17 that drove us to make a lot of change.
So our tipping point was a system called Impact. And from late 2016 to 2017, we built this new greenfield system where we didn't know the domain. We had new requirements, and we tried to move to new architecture. We separated the UI from the back end. So we ended up building a UI application that talked to multiple monolithic applications on the back end that communicated via REST and events. Though now looking back at it, I wouldn't call them events, more like just messages. So we did a lot of good things. We were able to run on Tomcat we wanted to, and we could deploy to WebSphere. But the change wasn't good enough, and we were still late delivering our system. It was supposed to go in May 2017. We delivered in June, and we had a month of firefighting. In the last month and a half of testing, we had over 1,000 defects. So at this point, we were just fed up, and we had reached our tipping point. We just said, what is going wrong with what we're doing, and how can we make it better? So the team did a retrospective. And the first thing we knew is that we had changing requirements. Our requirements never stopped evolving. And we started in the early of the third quarter of 2017, but in December, we had received a massive change to the impact requirements, which forced us to start all over again. And our deadline didn't change. It was still May 2017. And the organization would not reduce scope. So that was the first problem. And then the second problem we noticed is that we were basically doing database-driven design. Our DBAs took requirements and made relational tables, and then the team just made code that wrote and read from the database. And so our service logic, our business logic, was just getting data into the database, which is a very common practice with CRUD systems. It's just the way things were always done, the way we always did it. But it really showed us that we were really fragile, because our code reflected database terms, and we relied really heavily on ORM tools to do mappings. And then when development, we didn't have any real coding standards, and we had abandoned unit tests early on because as the service layer got more complex with all the confusion and things were going on, you couldn't write good solid unit tests that were easy to maintain. This was our first time we used Git, and we didn't stick to any prescribed Git workflows. We just tried to figure it out ourselves. And so we merged into a development branch. We didn't do any solid code reviews or quality checks. That development branch got built, and the builds, as the monolith increased its size, the builds got longer and longer, and deploying to Webster takes time. So our deployments would take up to 30 minutes on a check-in. The integration tests were mostly just developers testing their latest change, and that never caught things that they might have broke. And then every night, all the changes developers did were merged into a system test branch, which was built and had different properties and different things. It was a different environment. So we had a brand new application built and deployed into test where they did manual testing. So some of the problems with that was there was no traceability back to the code being moved in. It was very hard to trace it. And if there were database changes that had to go, maybe they didn't, maybe they made it, maybe they didn't. So tests would start testing, and there was a lot of confusion on what was the state of the code. And there was no automated test, so we couldn't find problems fast enough. And in the end, we were late. So we were ready to move on and try to figure out how to fix this. So in August, July, August, we were trying to rethink how we're doing stuff. And Joe and I had been reading Eric Evans' book on domain-driven design and trying to take things to heart. And I started looking at CQRS pattern in this, because we were always in our code updating and reading the database at the same time. And I thought that pattern might fix some problems. And then that led into CQRS plus event sourcing and made me really start to think. So we saw some positives with impact, and we saw some value in breaking things down. But we started talking, maybe we weren't breaking things down enough. And we started looking at microservices. And about this time, we were given the chance to rewrite an existing application that we already supported called Benefits Portal, which is a big monolithic 3-tier application. And it was going to need new features because it had to go out with the new modernized eligibility system, and it had to have a new UI. So we made the plunge. We said we were going to go straight to microservices with this rewrite, and we're going to learn how to do it. And some of the things, this was not conventional wisdom, but some of the things in our favor was we were pretty solid on the business domain. And so we just planted our stake in the ground and moved forward. But we ran into our first roadblock right away. The developers were not familiar with CQRS or domain-driven design. They were very happy with MVC CRUD systems. And so how do we move past that? We moved past it by doing a set of proof of concepts, or POC. So we did real quick, this took about a month. We did a proof of concept where the developers worked together to do a very simple proof of concept on domain-driven design and CQRS. And it helped solidify just the ideas of value objects and aggregates and bounded contexts and events. And that second proof of concept, we took a little bit further, and we started really focusing on the events. and took on event sourcing. We made our own in-memory event store, saving events as JSON, and mostly just focused on doing event storming and trying to find bounded context, trying to figure things out. We made up our own domain, and we were just working through it. But the team liked it. That was the thing. This team started to say, this makes a lot of sense. And we said, let's start saving stuff as JSON. Let's look at what our options are. And we hit another roadblock. We went to the Oracle team and said, hey, we want to start storing JSON in Oracle, or unstructured data. And even though it can do it, the Oracle team came back and said they would never allow JSON into their system or any type of unstructured data. And the space was also limited because the modernization project was consuming all the resources. So Joe wrote a business case, and he asked for approval to use Mongo, the NoSQL database. And I was already familiar with it. I liked the idea of using NoSQL. So we got a tentative approval, and we moved forward looking for frameworks to help us build this faster. And that's when we found Axon's Axon Framework. The team looked at it, we evaluated it, they liked how it integrated with Spring and Mongo, and it really focused on writing good domain-driven design code. But we didn't really cover microservices. So we looked at another framework called JHipster, which was built CRUD-based systems that could be deployed as containers. We liked that part. And so what we ended up doing was we blended the two frameworks. We used the JHipster framework to give us our microservice infrastructure and capability for discovery and things like that. And we used the Axon Framework for writing good, solid business domain code, and with the event sourcing. So we moved on. At this time, we wanted to do containers, and we approached the state agency in charge of IT, and we asked them, where can we deploy our containers? Do you want to go to AWS? Do you want us to go to Azure? And they hadn't made up their mind on what cloud provider they supported, but they volunteered and said they would build us a private cloud. So we moved on to phase one, just getting the developers going while the IT team built us a cloud. So that phase one, we were working on Benefits Portal. We already knew the requirements pretty well, but we wanted to rethink how we did stuff. So we started with event storming, and we went through and rethought the Benefits Portal from the events perspective, and it revealed how the system really worked. And it helped us. We already had a feeling what the bounded contexts were, but it helped us find actually the real bounded context. And when we moved and when we did our design, we stuck with simple things. We did simple notations, simple diagrams, but it got to the point where all the developers could draw an aggregate, an event flow, and figure out how to do stuff and enforce our concepts. And then we started writing code. And the development got easier because we were able to write unit tests. The Axon Framework has a really solid test fixture for writing unit tests against the aggregates or the Sagas, and we leveraged it to write tests that were always running when we were writing the code. And then when we went through our pull requests and stuff, we rethought that, and we stuck with Git workflow. And we just said, we're just going to follow what's prescribed instead of trying to do something ourselves. And the developers did pull requests into release branches. We did code inspections that looked for violations of domain-driven design and violations of the event sourcing patterns. And then with developers, because we weren't deploying anywhere yet, we were waiting for our cloud, they used Docker Swarm to build images locally and integrate locally, and they would demo. So we got through going like a month, getting some steam up, building stuff up. Still hadn't deployed anywhere. And then we hit our next roadblock. The IT team came back and said they didn't have the resources or the capabilities at that time to build us a private cloud. And they recommended us going back to WebSphere. We weren't going back to WebSphere. We asked the IT team, can you just give us some virtual servers and we'll do it ourselves? And that's what we did. They gave us our virtual servers, and we installed Docker Swarm on it. At the time, Kubernetes and Docker Swarm, those container wars were going on, and Swarm looked like an easy entry level into the orchestration game. And looking back, I think that was the right choice. But now in 2020, we've moved off of Swarm and onto Kubernetes. And Joe will talk about that later, about that transition. So the team, the operations team, the admins got Docker Swarm going, and then they deployed Jenkins onto the Swarm, and they got SonarQube running. And then things started kicking in. We were able to do pull requests that had quality checks that we controlled, that making sure that we weren't duplicating code, or we had enough test coverage, and it took some work off of us to let that automation take place. And then we got into CI/CD, so the team worked together to build a pipeline that built and deployed the code on check-ins once the merges happened. And we started picking up speed because the builds were taking only 5 minutes. Deployments were taking 5-6 minutes to get onto the swarm. And then when the testing was done, we just promoted the last image that was deployed to development into test, and we had complete traceability over the commit IDs, and we knew what was going on. But then we ran into one more problem, or two more problems. One was we still had manual testing and test. And we asked the test team, can you automate these things? We have REST APIs now. Can you automate this stuff? And we got pushback. They didn't have the resources or the time to take that on. And the other problem we had was the state could not decide on a SIM tool for us to use. So the developers who were in the Webster world were used to going to a couple different servers looking at logs. Well, now we had these containers having logs and trying to figure out how best to access them. Well, we knew what we wanted to do. We wanted centralized logging, but once again, the state couldn't make up their mind on what to use. So we got past these roadblocks just by pushing forward. And the first thing we did was we installed Elastic. Elastic was free for us to use. There's paid versions. We don't have those. We just stuck with logging. JHipster, the framework, has capabilities to write to Logstash. So we just turned that on and we started getting logs. And with Axon's event tracing we turned on, we were able to trace our events through the system. Developers get a good idea of how things were working. We were able to troubleshoot problems quickly. And then, but by luck, we had a couple of testers approach us wanting to become developers. And we talked to their manager and we thought, well, why don't they start writing automated tests for us with code or whatever they want to do. And they looked around and they stuck with Postman, and they started writing Postman REST API tests and started running those every day or every night. And in about a month, we started having automated acceptance tests every time we deployed. And we started picking up more speed. We had the monitoring going on. And so at this time, we got a big win. We were asked to build a new project, a greenfield project this time, called Achieve. It had a deadline of January 1st, 2019, and this right now was May. When we got awarded, this was May 2018. And it just got legally approved. And so the requirements were not done yet. And of course, we said, we'll do it. But then we had a big roadblock. The team did not know the domain. We did not know really what Achieve was supposed to do in a business sense, even though it serviced a subset of the benefits portal users. Is another way of helping them get their benefits. So how do we solve this roadblock? And this is where things really came to fruition. We took on a new technique for us called story mapping. In that we worked with our client, we worked with the agency, we worked with business analysts, and we wrote out features and user stories about how the system was going to be used. And we mapped everything back to the legal requirements. We figured out what had to be done. And when we did that, we realized, like mid-May, we realized there was no way we were going to have this running by January 1st. It just couldn't be done. But with the story map, we were able to talk to the client and we were able to identify those things that didn't have to go in January. And we got the client to agree on a most viable product and MVP. And so we had a scope that we thought we could do. It was still going to be tight, but we thought we could get it done. And so we moved on into our event storming from the story mapping. And we found our bounded context. The team, since all that story mapping had done, also gave us a vocabulary to use. So we were familiar with the domain, so we were talking to everybody with the same words. And that helped tremendously get this done. And when we got to development, we noticed something else from the story mapping. With all the work we'd done, figuring out the stories, we had a lot of testable scenarios at the business level. And we were able to try test-driven development. I'm kind of a quasi-fan of it. I think it works best when you know what you're going to build, and then you go and test it as you go. And we did that, and so we leveraging Axon Framework's testing fixtures. We wrote really solid unit test code and got it out there. And Achieve was way more complex than Benefits Portal as far as its business rules. But we followed our process. We didn't have to take on new infrastructure or the new team. We just took a few developers from our existing team and put them on Achieve. And we all worked together in parallel using our cluster, our orchestration environment, and we released on time. For the first time in a long time, we released 2 projects, Benefits Portal and Achieve, in parallel in December of 2018, and they were live in 2019.
So you've heard a lot about how we've changed our processes, our technology, and the teams really changed with the implementation of 2 systems at the beginning of 2019. But what about the business outcomes? You know, we all know it's not about the technology, right, or the architecture. So have we been able to deliver what the business needs? Have we been able to reduce the opportunity cost when change comes about or the business has a new need? So now what we want to do is talk about how we've been able to meet the needs of the business and really change the mindset of our development team and our development efforts. So an example we want to reference has to do with COVID and this doc upload functionality that the business really need. So we're in the time frame of April 2020, and at that point, FSSA had closed their offices. You know, no longer could you have person-to-person meetings or contact, which was really kind of the business model for applicants or people, clients that are applying for benefits would come into an office. Although they can do this online, a lot of them would come into offices for a meeting and provide documentation as part of the intake process, which helps the system determine if you're eligible for a benefit, or in some cases a redetermination to continue your benefit. Now with offices closed, they're relying on receiving those documents through mail, which was slow, or through email. So now the process, they're getting backlogged. And they came to us with a requirement to say, hey, we need to allow clients to be able to upload documents. Now, that was about it on the requirements. They didn't provide information about, well, hey, how do these documents get indexed? What's the volume? So they did, however, provide a new requirement that they wanted us to leverage security functionality, which is called CDR, content disarm and reconstruction. They did want us to do that because they didn't want us to introduce malicious code within documents that we would allow somebody to upload. But when we looked into that, there's nobody else in the state doing that. And, you know, they weren't worried about attachments on emails. So we took this on and started to leverage the foundation that had been laid in place with the process and the transformation that you've heard about. So now, again, we had to drive out our requirements, and we leveraged story mapping and event storming. And now we're able to define our bounded context, define our aggregates, define our events and commands, and leverage the design process that we had in place and produce a product really quickly. We also leveraged, besides the Axon Framework, we leveraged Mongo's GridFS, which now allowed us to store documents. So how fast did we do this? Well, in 5 weeks, we were able to drive out the requirements, to understand how the volume of documents we needed to support on a daily basis, which we drove out based on historic numbers that we needed to support over 1,000 documents an hour. We drove out a user experience that supported a phone, supported the drag and drop. We also did all this with 4 developers. That includes a UI developer. In addition to that, we were able to integrate with our document management system, and along the way build out our automated tests. Code coverage was above 80%. With this product now, this also reinforced the idea that we have isolation. Now we had a new bounded context we called the document upload, but we didn't have to make changes to our other bounded contexts like application or client. Now we were able to just deliver a new service, and things worked. In addition, with regards to the security, now we had an asynchronous process where we could receive documents from the client, send in confirmation, and then before sending the documents into the network further into our document management system, now we were able to leverage an API from a security provider to get the CDR functionality we need. All of this accomplishment really demonstrates the value of the event-driven microservices and the value of leveraging the event sourcing with CQRS and the Axon Framework. Now we want to talk about how change has really changed the mindset and our development approach.
So the first mind shift we had was building data models from events. And prior to this, we always had our DBAs make relational tables or make views. And if we want to drive a screen, we would write queries, and we use Hibernate to pull things together and drive the screen. Well, with the Axon Framework, with this new architecture and event sourcing architecture, we moved to having the query service that just processed the event stream as the commands appended events. The query service would read those events, and then we would use the event handlers in Axon to update or insert documents into Mongo. And it was not it was a difference change. We didn't use an ORM tool for this. We just wrote straight up Java code to access Mongo, and the team adapted to it. And we really kicked in was in mid 2019 after Achieve went live. The agency wanted reporting, and we didn't have reports at the beginning. But we were able to replay the previous events and use the rich metadata about who had changed things, the timestamps about what was going on. And we were able to build rich historical reports after the fact. And that was a game changer. And we started applying that kind of thinking in their places. Now, this did lead to one thing early on when we first started discovering how to use the event stream to build queries, to build documents. We had a problem with trying to enforce CQRS. And so our original architecture had one microservice with the command handling and domain model and the query handling all in one thing. And we did our proof of concepts. There was a lot of confusion about whether or not it was okay for when the commands were being handled, why not just update the query models as well? There was a lot of confusion. Why can't we just do that? You can do that, but you shouldn't do that. We didn't want to do that. And so to kind of enforce a better practice, we split our architecture into two. So our bounded contexts generally have microservices that do command handling. They're the C in CQRS. And then we have query service that just do the query handling. They get and they process the event stream. They're responsible for building the data model that drives the screens or drives reports or drives whatever it needs to do. So when we did this, it was harder for developers to get going because we had two services working together right off the bat. But they adapted to it, and it started enforcing a good habit, I think. And it worked. And in the end, we got some nice things out of it. Was we were able to independently scale these two services. When we went live, we could scale query stuff. If something was heavy on reads, we scaled the query side. Heavy on commands, we scaled the command side, and it gave us a lot of flexibility. So that in the next mind shift was going back to how we used to do things. Like Joe was alluding to, the state is happy with large batch driven applications. And we didn't want to do that anymore. We didn't want to have a scheduled time where during half the day we were running queries against our system. So we leveraged the event-driven microservices for this. We replaced, I guess, one of the biggest problem with the batch that we saw was it led to a fractured bounded context. You had the batch server, which had business logic, and you had the applications with their own logic. And we wanted to move away from it. And so with our bounded context, everybody was responsible for what they could do. And they communicated over events. So we were able to leverage that event-driven thinking to replace the batch jobs. For example, when we want to deliver an application, and it failed, or we want to generate correspondence. Correspondence is a good one. You have business rules determine what type of correspondence. And at the usually when the batch approach was at the end of the day, you run queries against everybody to find out who needed what type of correspondence. Well, with the domain-driven design and the events, we just when a state change came in that that particular person needed a particular type of correspondence, we would fire off an event to generate that correspondence. If there was ever a question about what type of correspondence was needed, we scheduled a Saga to run later in the day after we assumed the system would quiet down, people would be done entering their data, and then the Saga would trigger, and it would orchestrate generating the appropriate correspondence. By doing this, not just with that example, but all over Benefits Portal and Achieve, we were able to not have batch jobs anymore, and that was a big game changer and a mind shift. The last one goes back to Sagas as well. We typically in the state infrastructure, if one system goes down, everything goes down, and we didn't want to do that anymore, especially with the new modern eligibility system. It had long deployment weekends. A deployment for it would be 3 days or tens of hours. And when that happens, you don't want to have the client who needs benefits from not being able to at least apply. So what we did is we made our system more resilient by leveraging Sagas. If for example, in this example here, an application needs to be delivered it gets signed by the client, it needs to be delivered to the eligibility system. And if the eligibility system is down, now we schedule a Saga to run to try again in a specified amount of time. And that time would progressively get bigger as longer the eligibility system is down. And by doing that, we were able to just collect the applications. The client would see a status that their application was signed but pending to be being delivered. They were happy, they had some feedback. We had logs that would show us as these events flow through the system. We could see if the eligibility system was down or where we were at, and get a good we made dashboards on our application delivery flow. And then when the eligibility system would come back up, all the applications would end up getting delivered. And we just had a big win with this just 2 weeks ago. The eligibility system was down, and we didn't put any maintenance pages up. We collected applications, and they were down most of the weekend. And by Monday morning, all the applications had been delivered. It was around 5,000 applications over the weekend came in and were all delivered. This works. And that was another mind shift we had, another pattern of building this resiliency into our system that developers have adopted, and it's worked really well.
So now we want to talk through just a few other achievements that the team has been able to accomplish. So with the architecture now, we've been able to upgrade or enhance functionality within services independently without having to take on the whole system through an upgrade. We now can target just specific services. And besides upgrade, maybe with libraries or the framework, but also when I say upgrades, that might mean taking advantage, for example, of the Axon distributed command bus for certain services that we need to use that functionality for scaling before we do that for other services. So it's really allowed us to prioritize and, again, react to what the business needs and the system needs. Zero downtime deployments. With COVID, this has been a real benefit. Now, there's been numerous times now where the business has required changes, and now we can make those changes very quickly and actually deploy those changes midday. We're no longer bound to this, hey, we got a change and we need to coordinate a big down window, whether that's in the evening or some Saturday effort to do. That's not even a burden for us anymore. We know how to work through our change, and deployment is simple. Scaling. We've mentioned scaling throughout the presentation, but with COVID, and now you have changes in users' behavior. For in April, a lot more people are applying. So now, instead of having to worry about scaling a large monolithic application vertically or horizontally, we just need to worry about scaling a particular service. So now we're very reactive to what our user traffic is and what the business needs. And then, a final one here is it's hard to measure, but we've moved from Swarm to Kubernetes. And this is really possible by the fact that now with this architecture that we've been supporting now for over a year and a half, and the skills, the transformation that our team's made, now we're much more efficient with change. And the system is stable. And what this has allowed us to do is take on other opportunities, as I put it, or reduce the opportunity cost. Now we were able to allow Andy and a small team of people to focus on this migration from Swarm to Kubernetes. And we didn't have to worry about the application, and certainly the services themselves didn't care that we were going to Kubernetes. So the message here is that the whole architecture, the whole team transformation to the new technologies has really been beneficial to not only the IT organization, but also to the business. So we wanted to go ahead and talk through this slide. As you, to me, this is a difficult slide to talk to, because if you read a lot of the material out there on microservices, there's a lot of very smart people that give a lot of information out there, and we certainly tapped into all that over this time, and we continue to do so. But a lot of the recommendations or conventional wisdom out there tells you that, for example, don't focus on the technology. But when we look back kind of retrospectively at what we did focus on the technology, particularly at the end of 17 and the beginning of 18. And that worked for us. It was important that we put that foundation and addressed our technology and processes up front. There are also some recommendations about you should avoid microservices, build the monolith, and then when you have a good reason, target certain functionality and move that to a microservice. For us, moving to microservice, we built monoliths for so many years, and we always fell into this trap of underestimating the complexity of our applications, or thinking these apps are simple, they don't really have a lot of change. And we always underestimate these things, and then we pay the price for years and years later trying to support them, and the cost of supporting and building up. And we moved away from that. We said, even though we have the benefits portal, we knew the domain really well, and we moved forward with microservices. And what we learned there, then we took on a new system with Achieve and build it from scratch. And it's really paid off for us. The idea too that, your default should be a monolith, or, your default shouldn't be microservices. Well, for us, the default became microservices. Our processes and our technology allowed us to be real effective in implementing new systems with the technology and the tools. And lastly, the idea of leveraging common code. We've really moved away from building some common functionality that we try to use across our different services or even monoliths. We've really moved away from that, because when we were doing that before, now we had to get into the versioning, and now we had to manage that as we changed applications. Well, we want to thank you again for attending our presentation, and now we're ready to address any questions you might have. Thank you.